G'day viewers. In this segment I'll give you an overview of the application layer material we'll cover. Okay, so first of all, congratulations are in order again. We're moving on to here, the application layer, having covered all of the lower layers of the network so far. And the application layer is where all of your favorite applications live. The web, YouTube, Dropbox, whatever it is you like. So in this unit we're going to learn about some of those applications, focusing mostly on the web, as well as we'll use the domain name system, which translates host names to IP addresses as an example of an application too. All of these applications are really building distributed network services, you might think of as things that use the network, that is, on top of the services of the transport layer, which we've covered already. So just a little bit of a refresher before we dive into the details. Here's our protocol stack again, just spelled out in a little more detail. And I want to draw your attention to this blob, which is really an app or an application. Now interestingly, inside it there's an application layer protocol. I'll often use app and application layer, the application layer protocol, and all of those things synonymously. That's fairly loose, so really the app is the program. It contains an implementation of an application layer protocol. Here HTTP is the application layer protocol. App layer protocol. That's part of the application. And I've also drawn the lines just to remind you of where this functionality is typically implemented in systems today. So the application, including the application layer protocol, is something which usually runs at user level on traditional operating systems. And in the operating system, we have TCP/IP and everything below the application level, essentially, down to some of the lowest layers, the link and physical layer, which can be implemented as part of the NIC in hardware, the network interface card. Now, one thing I want to call your attention to here is that application layer protocols, they don't necessarily need a GUI. So this is why, from our point of view, something like the DNS, the domain name system, which we'll get to later, but I'll tell you now, it translates host names to IP addresses. That is an application layer protocol from our point of view, even though it's something that doesn't really have a user interface and you might not otherwise be aware of it. You might think of it more as a network service. I'll also give you just a little bit of a refresher on the protocol layering, how it manifests itself in terms of structure on the networks. The only real point I want to make here is that typically many application layer messages will be relatively large. So here's our long HTTP message. This was an image in a web page coming back or so forth. This won't fit in a packet. So to be carried across the network, it will be split into multiple packets. Or segments, if you like, transport segments, where a TCP transport segment is typically carried in a single packet. So we'll loosely use packets. So you can see here that pieces of that HTTP message are sent, one piece within each different packet. So there are extra headers here. Of course, the application layer doesn't see all of this because all of this dividing things and putting the headers on is in the TCP and IP layers below the application layer. The application is using the services of the transport layer, so it's just seeing a byte stream if we're using TCP in this case. Okay, so that's just the protocol layering to relate it to some of our basic concepts. Now let's move on a bit towards applications. Okay, well, one of the difficulties with talking to you about applications is that applications are a very diverse set of things. An application does, well, whatever it is you want it to do. So these apps vary widely, and their communication patterns vary widely too. I can tell you that whatever their communication patterns are, and they do vary, they're going to need to build them on top of the services the transport layers we're already providing. So I've sketched 3 examples for you here, just to think about the different kinds of communication patterns. Now on the left here we have the web, and the real communication pattern need for the web is a series of variable length and reliably transferred request-reply interactions. So this is where you fetch a web resource, and you typically do this many times. There's a whole series of them to build a web page. This kind of communication pattern is going to be built on top of TCP in the case of the web. TCP already gives us the reliability and the variable length messages as part of its byte stream. So we'll need to build a series of request-reply interactions on top of it. That's the web. A completely different example here is in the middle. So the domain name system, its need is for, it says here, short, reliable request-reply exchanges. You'll have to trust me because we haven't seen the DNS yet, but it's going to send a series of very short messages to ask for these translations. Because it really needs to send short messages rather than a variable length and possibly long byte stream, it builds on top of UDP. So and you can see I've shaded this, this box as a little mix between all of the grey and the pink, because I would actually like to point out that DNS is something that would like message reliability but not a byte stream. So it's a little stuck in terms of the transport services. It sort of wants something in between TCP and UDP, right? We wanted the reliability but not the byte streams. That didn't exist as a transport layer service, so DNS at the application layer will build the reliability itself. So it's really almost building a bit of a transport layer because we didn't have such a good fit. And on the right hand side I have an example of Skype. Skype also builds on UDP. Skype is really just a stand-in for a popular real-time conferencing application that's sending around audio and video between live participants. The reason to build on top of UDP normally is that there's no need for reliability. The communication needs to be real-time, so if the information doesn't arrive quickly by a deadline, there's no point retransmitting it so that it can arrive later for the sake of reliability, because everyone will have already seen a glitch in the conversation and moved ahead. So Skype somehow needs to implement a real-time stream delivery communication pattern on top of UDP. So these top boxes that are in the pink, or the grey and the pink in the middle, are the network communications that these applications are going to implement. And we'll look at some of them in a lot more detail. What else can I tell you about applications in general before we dive into specific applications? Well, one other thing I can tell you is, that I can remind you of, is one of our reference model slides from the very beginning. You remember this old OSI reference model? You might have recalled that it had these session and presentation layers between the transport and the application. Now, we're not going to follow a strictly layered model and have any of these layers in our applications. Nonetheless, I'm pointing this out because both sessions and presentations are very much two relevant concepts, and most applications will express them in one way or the other. They won't be coded in a strictly layered fashion as in this protocol stack, but there are still things which are worth thinking about within the context of applications. So let me give you a quick slide on each of those. So what's a session? A session is really, it says here, a series of related network interactions. And they're done in support of a common application task. Now, often because we don't have a strict session structure, this task will be informal rather than explicit. But I'll give you a couple of examples here. In a web page, simply viewing a web page, you end up fetching a whole series of related web resources, the text of the page, associated images and style sheets and so forth. So the session is this overall page fetch, which is made up of the many component fetches. A different example would be a Skype call. A Skype call involves a session because it often won't have simply one stream of information flowing over UDP. It will have a series of related activity. In a call, for instance, you might have audio and video and chat messages, and they all need to be coordinated and used together in support of a common goal, that conference call. Okay, what about the presentation layer? Well, the point of the presentation layer is, as it says here, apps need to identify the type of content as well as encode it for transfer. That's what the presentation layer concepts are all about. So some applications might only want to deal with one kind of content, but for many kinds of applications, if you just think about the web, that application will deal with many different kinds of content and want to handle them in different ways. If there are multiple types of content, we're going to need to say what kind of content is carried and what kind of message. And again, I'll just give you a couple of examples of how this is often done in practice. A very common standard on the web, and it's used elsewhere too, for specifying the type of media are the so-called MIME types. Originally this came from email. Multi-part internet mail extensions is what MIME stands for. but it's really more relevant these days for the web. An example of a MIME type is image/JPEG, and there are many more that you've probably seen in different places. Text/HTML, for example. These MIME types or media types identify the type of the content. So often application layer protocols will carry meta information, such as these MIME types, to describe the content they're transferring. As well as the content itself, there's also something distinct called a transfer encoding. Just because you've got a particular content like an HTML file, it doesn't tell you what format is going to be sent across the networking. For instance, one common transfer encoding might be gzip. You might decide to gzip the contents. Or you might not. If it was a JPEG image, gzipping it probably wouldn't do much good. So that's a transfer encoding. Now, and I would also point out that often these application layer headers tend to be simple and expressed in a way which is fairly easy to read, rather than compactly packed, say with a binary encoding for reasons of efficiency. That's because these headers are usually small compared to the contents, and a great amount of value can usually be obtained by making them easy to see. For instance, when you debug it, you can just look at the contents of the messages much more easily. Okay, so Internet applications. I said that they are many and varied. In fact, one of the few things you could say about Internet applications in general is that they're always changing and evolving and growing. This timeline just gives you a sense of the dominant Internet application and how it has changed over time. In the beginning, around 1970 or 1969, we really started with Telnet as an application. This is a remote terminal to a remote computer. Today we would use a more secure version called a secure shell, but nonetheless Telnet was a very early dominant Internet application, along with file transfer as a utility. Email in various forms was actually the first killer application of the Internet that took off very soon after the Internet, or ARPANET at that stage, began to grow. And email was the dominant application for quite a while. Then we began to get to other richer kinds of content. Network news, if any of you remember that, it's a precursor to the web, a different form of content where really text was being sent around, but news groups was one sort of interesting other kind of content which rapidly increased in volume. But all of this was completely dwarfed when the web came along in the early 1990s. And the web itself has grown through several different phases. It's initially started off with clients talking directly to servers. But as very popular sites became more and more popular, content distribution networks were really embedded into part of the web infrastructure. And the traffic that was served by content distribution networks dwarfed much of the other traffic. In the middle here, there's another kind of application which became very popular for a time, still is, peer-to-peer file sharing with protocols such as BitTorrent. As digital audio and video and other kinds of content proliferated, there was a need to transfer them, or at least many people would transfer them without using any kind of centralized infrastructure, clients helping themselves. That's this peer-to-peer system, which we'll eventually see some of. The web itself has also these days grown very much in the direction of video. So the bulk of the traffic on the internet is probably video that's been streamed across the web, with slightly different protocols. In all of these, it's always called the web. Everything is the web. But as we go up these steps, often the way the protocols are used changes slightly to support the different kinds of usage. So the web is certainly a big application which has many pieces to it. And what's next? I don't know. Your guess is as good as mine. Maybe it'll be some kind of content caused by all of this Dropbox traffic. Who knows? Maybe it'll be something else entirely. We'll see. But the one thing that is for certain is that there will be something new up there, and it will transfer more and more traffic. This is how the web evolves. If you are interested in finding out a little bit more about the evolution, really, of the way we use the web, the different applications, there are all sorts of resources out there you could take a peek at. I've just provided some pointers here to some that I look at fairly regularly. Akamai runs a State of the Internet report quarterly that gives you some data on the traffic they serve and what they see that's going on. Cisco also annually publishes a visual networking index which contains forecasts of how internet traffic is growing and changing. And Mary Meeker is also well known as an analyst who pulls together different sources of information and gives you her view of where the internet is heading. Out of all of these different sources of information, there are some points that I think you could take away for where we are right now in the web, and I'll just highlight them briefly. And in some ways this is about traffic, but all of this traffic is very much driven by applications. That's why I'm talking about it now. So today, the growth of the internet is still robust. It hasn't capped out or anything, it's still very much growing, especially in the dimensions of video, wireless, and mobile traffic. Most of the traffic from the applications we have is video today. It's the majority of the bytes that are sent over the internet. And predictions are that if current growth rates continue, we'll be at 90% of the traffic on the internet being video within just a handful of years. Of course, the way the internet works, in those handful of years, a whole new application could come along and dwarf everything so far. Wireless traffic is also growing. Wireless traffic is right now just a little less than half of the internet, but it's soon predicted to be the majority of traffic will come from wireless links to the edge of the network. Mobile traffic, which comes from smartphones, is still a small portion of the overall traffic, around 15%, but it's growing quickly. All of these dimensions are growing. And interestingly, there's also been observed growing amounts of attack traffic, large denial of service attacks and other kinds of infiltration. So this much of this has come from China, if you read all of your newspapers, but there's also a fair amount of attack traffic that comes from the US and Russia. So the web is also evolving very rapidly, not simply different internet applications. And here's a visualization I just wanted to show you. This comes from evolutionoftheweb.com. And you can see here this really pretty amazing graphic picture shows some of the different technologies, not simply HTTP that starts on the very far left in 1991, but as we go ahead over time, different browsers appear, starting with Mosaic, then Netscape Navigator, Opera, and Internet Explorer. And there's a whole proliferation of different technologies here, different kinds of HTML, scripting with JavaScript and Java and Flash, HTML progressors and so forth. And as we go to the right, not only do new kinds of internet browsers, not only are they developed, but, sorry, I'm just stunned by the mess here, as different kinds of web technologies that are now present in your browser are all developed. Okay, so out of all of this picture, the part we're going to look at, that I'm going to talk about as relevant to the network, is simply this path. This is HTTP and its evolution. Nearly all of the rest has to do with the execution of content on browsers and servers and the kinds of content itself, like HTML, and that's a little bit wide of our purview. So we have a lot to look at already just with HTTP, but it's only a small part of the picture. Okay, so we'll look more at applications in some of the coming segments. We've gone over the evolution of internet applications, and now we're going to select just a handful of applications to look at. First, I'm going to tell you about the DNS, the domain name system, because that's really a crucial service translating the host names to IP addresses that we can use. Then I'll switch to the web by telling you about the Hypertext Transport Protocol, HTTP. And we'll just have much to discuss about the web, including how different kinds of caching works and content distribution networks. We'll also get to peer-to-peer systems such as BitTorrent at the end, just really to provide an alternative to show you a protocol that's a little different than HTTP. And finally, not in this unit, but later on, we'll get to real-time applications such as voice over IP. And I'll separate out that last application and treat it differently when we cover quality of service, because in that respect it's quite different than the other applications. Okay.